So we'll be continuing from dimension, as you can see on the board. And we say that dimension or dimensional analysis, anyone you want, you can say dimensions of physical quantities or dimensional analysis of physical quantities is defined as the mathematical expression of the physical quantities in terms of the three basic quantities, which is the mass, the length, and the time. I'll repeat it again. We say that dimensional analysis or dimensions of physical quantities is defined as the mathematical expression of physical quantities in terms of the three basic quantities. And the three basic quantities are mass, length, and time. I would explain what I mean. The three basic quantities are the mass, length, and time. And now, the dimensional analysis is the mathematical expression. And for us to express mass mathematically in the dimensional analysis of physical quantities, we express mass or denote mass as capital letter M. For us to express mass, we have to use the capital letter M to express mass. And then for length, to express length mathematically in dimensions, we use the capital letter L. And to express time in the dimensions, we use capital letter T. Now, in dimension, we replace the unit, the SI unit of these quantities or the SI unit of physical quantities with the dimensional analysis ML with the three basic dimensional analysis, which is MLT, which is for mass, length, and time. Let me give you an example of what I mean. For us to express mathematically area or in dimension, for us to express area in dimension, we say area, we state the formula first. We state the formula for area, and we say the formula for area is length times breadth. And we know that the SI unit for length is meter or m, and the same thing for breadth, because SI unit for breadth is meter as well. Height, breadth, length, width, depth, all of them is measured in meter. Distance, displacement, all of them, their SI unit is meter. I come again. Length, breadth, width, height, depth, distance, displacement, all of their SI unit is in meter. Is in meter. So for area, the formula for area is length times breadth. And from our previous class, from our physical quantity, we said that the SI unit for area is meter squared, because m times m here will give you meter squared. And for us to get the dimensional analysis for area now, we say the dimensional analysis for area is equals to, we say that anywhere length, in the dimensional analysis, we say that we represent length or meter. Anything meter in dimensional analysis, we call them length. And for us to express meter in the dimensional analysis, we use the capital letter M. Sorry. We use the capital letter L, sorry, to represent it. So the dimensional analysis now for area becomes length times length equals to L squared or L raised to power 2. This is the dimensional analysis for area. Let's do for volume. For volume, we do the same thing. Volume is area times height. Area times height. And from our dimensional analysis, we know that area is L squared. So we have gotten this one already. So we put L squared. But now we have to find for height. And from here, I told you that height is also measured in meter, meaning that anywhere we see height here, the SI unit for height becomes meter, or we represent it in meters. Then for us to get the dimensional analysis for volume, we say L squared times L, which will give us L raised to power 3, because there is invisible one here, though we don't write it out. In indices, the product rule says that if we have A raised to power 2 times A, sorry, if we have A raised to power 2 times A raised to power 4, that in indices, this product rule states that if we have the same base of anything carrying different numbers, different index power in their head, that we have to plus the index power. So automatically 2 is plusing 4 to give us, and we now take one base because they're still the same thing. So we now call out one base and say A raised to power 2 plus 4 will give us 6. So that's exactly what we did here and here. So let's continue. And this is for volume. Let's do for speed. For us to get the dimensional analysis for speed, we have to state the formula for speed. And we say speed is distance over time. And from what I've said here, distance is still measured in meter. So we say meter over time is measured in seconds. So we write meter per second. And for us to get the dimensional analysis, we say meter is L, which is length. So we use capital letter L here, over seconds is time. Time is capital letter T, so we use T here. Therefore, the dimensional analysis for speed is equal to L over T. And then we are not done yet. We have to take this T up for us to be able to represent it mathematically. So we say dimensional analysis is equal to L T raised to power minus 1, because this T is crossing over. Whenever this T crosses over to this side, or whenever a base, the same from indices, whenever we have something like this, L3 raised to power T2, whenever we have something like this, whenever we move anything from here to the top, the power becomes minus. This power here, the sign changes because originally there is a plus sign here. So whenever it goes up, it becomes L3 raised to power L3T raised to power 2. That's the same thing we're going to do there. So this T is crossing over to become, since this T is coming over to this place, we say the dimensional analysis for speed becomes LT minus 1, because there's an invisible one here. There's an invisible one here. And when it crosses, the sign changes to minus 1. So let's do for velocity. For velocity, we have displacement, because we have to state the formula first. Displacement over time. Then we get the SI unit for velocity. The SI unit for velocity is meter per second, the same thing as speed. Since we already know for speed, L over T, we say the dimensional analysis for velocities. We say the dimensional analysis for velocity becomes L T raised to power minus 1. Just the same thing. Then let's do for force. For force, we say force is equal to mass acceleration, mass times acceleration. Let me write it here. For force, we say force is equal to mass times acceleration. What is the SI unit for mass? The SI unit for mass is kilogram times what is the SI unit for acceleration? For us to get the SI unit for acceleration, we have to know the formula for acceleration. So we come here and say acceleration is equal to velocity over time. We know the SI, okay, velocity is measured in meter per second all over second. Acceleration is equal to meter over second divided by seconds. And then we have to change this division sign to multiplication sign. So and when we change it to multiplication sign, this one goes up and the s comes down. So it becomes meter over s times 1 over s equals to meter over s squared. So acceleration becomes meter per second squared or meter per second squared. You can write it this way or you can write it this way. Now, for us to get the dimension for acceleration, now the dimension of acceleration becomes, we know that L is for meter and T is for time. So you just carry this 2 and put back here. So it becomes LT minus 2. Now, we have gotten the dimensional analysis for acceleration. So we say LT minus 2. Now, what is the dimensional analysis for mass? Kilogram is the SI unit for mass. So now, for us to get the dimensional analysis, we have to represent mass with capital letter M. So we replace this kilogram with capital letter M times LT minus 2. So now, the dimensional analysis for force becomes MLT minus 2. So now, the secret to getting these dimensions of any substance or of any physical quantity, sorry, is knowing the formula. Knowing the formula helps you get their SI unit. And once you have gotten the SI unit, then you can get the dimensional analysis. This is very easy. Very, very easy. I have a question here that says, at what respective value of x, y, and z would the unit of force in Newton be dimensionally equivalent to m raised to power x, l raised to power y, and t raised to power z? What is the equivalent value of force in dimension? Would x and y and z be would the value of x and y be equivalent? So now, to solve this is very easy. There is no problem in this life that doesn't have a solution. This is like the easiest question in dimension. For us to solve this, we have to note some things. Force, the asking us for force here. So it means that we are working with force, the physical quantity, force. And then they already gave us another hint, dimension. We have to be working with the dimensional equivalent of force. So we have to find the equivalent unit of force because the unit of force, the SI unit of force is Newton. So we have to find the equivalent unit of force, and then we have to find the dimension of that equivalent unit. And the question in total is asking us what is the value of x, y, and z. So we are looking for the values of x, y, and z in this question. Solution. For us to proceed, we say force. We have to state the formula of force. Force is equal to mass times acceleration. And we know that the SI unit of mass is kilogram. The SI unit of acceleration is meter per second square. Now, remember, there's a multiplication here because we want to get the equivalent unit of mass. We have to get the equivalent unit of force. So the equivalent unit of force becomes kilogram times meter per second square, which is kilogram times m over s square, which will give us kilogram meter over s squared. We can take this one up here to make it kilogram meter per second squared. So this is the equivalent unit of mass. Of this is the equivalent unit of force. Now, because I said in what respective value of x, y, and z would the unit of force be dimensionally equivalent? So they're asking for the dimension of the equivalent unit of force. So back to our dimensional analysis here, we say that anywhere we see mass, we use capital letter M. Anywhere we see length, we use capital letter L. And anywhere we see time, we use capital letter T. The SI unit of mass is kilogram, the SI unit of length is meter, and the SI unit of time is in seconds, which is what we have here. So we have M, L, T. That's what we have. So putting it back in this, writing it well, we see that the dimensional analysis for force is equal to m raised to power 1, l raised to power 1, and t raised to power minus 2. We have to put this minus 2 here. So this is the dimension equivalent of force. But now they're asking us what is the value of x, y, and z. So we have to equate this dimension of force to this this figure here, this um, equation here, this project here. We have to equate this one to that one. So we say m1 l1 t minus 2 is equal to mx y sorry mx l y t z. M will cancel m, L will cancel L, and T will cancel T. So x is equal to 1, y is equal to 1, and z is equal to minus 2. So the dimensional equivalence of force in this equation is m1 l1 t1 t minus 2. And now the value of x, y, and z. X is equal to 1, comma, y is equal to 1, comma, and z is equal to minus 2. And this is our answer. 1, 1 minus 2. This is our answer. So we go to our option, and this is our option. This is very easy, very, very easy. Whenever they give you a question like this, first of all, get the formula of that physical quantity, get the formula of the physical quantity, and get the SI unit. You don't need to know it often, just know the formula first. The formula will save you a lot, and then change it, process it down. We know that mass is in kilogram. That is why you need to know the SI unit of your physical quantities. If you don't know them, you can't solve this. It will be very, very easy for you if you know the physical quantities and the SI units. Go and watch the previous video to see what physical quantities are. Thank you.